Hello, everyone. Okay. So yeah, as I was introduced, I lead the Data Science Engagement Group at NERSC, and that means that my group works with experimental facilities like the JGI, like KBase, user facilities in the DOE complex. So in case there's anyone here who's unfamiliar with NERSC, we are the mission HPC and data facility for the DOE Office of Science. And what that means is that we provide computing for scientists across the whole Office of Science. This means that we have a lot of users. We have even more users than JGI does. Something like 7,000 scientists run on our machines across something like 800 different projects. So one of the things that we've really noticed in our workload as that's kind of been evolving over the years is that we have an increasing number of scientists who run on our machines who are primarily doing data analysis. When people think about supercomputers, they tend to think about doing large-scale simulations. And we certainly have a large workload of scientists who are running big simulations at scale, but we also have increasing amounts of scientists doing data analysis, and particularly data analysis from the DOE user facilities. So something like 35% of our users currently identify as being primarily involved in data analysis. And as I said, this is increasing. And the needs of these scientists are really driving the way that we think about designing our supercomputers and the way that we architect our infrastructure. Because we recognize that scientists doing data analysis might have slightly different needs from the scientists doing large-scale simulations. So the way that we are thinking about designing our supercomputers is changing somewhat, and I want to sort of talk a little bit about the machines that we have on the floor at the moment and our upcoming supercomputer. So at the moment we have Edison on the floor. This is going to be retiring. Edison is retiring next month. So our main machine, our main supercomputer is Cori. And then in something like 2020, we'll have our next generation machine coming on the floor, which is NERSC 9, known as Perlmutter. I'm just going to talk a little bit about some of the features of these supercomputers that are, I think, really of interest to this audience. So Cori is our main supercomputer, been on the floor for about 2 years now. It's the number 12 in the top 500 list, which means that it's the 12th most powerful computer on the planet. When we first deployed Cori, it was number 5, but in just 18 months, we dropped to number 12 because technology moves really quickly in this world. So a couple of things that I want to point out about Cori in particular is that we made investments when we were designing Cori to support data analysis and support large-scale data analysis. Some of these included supporting containers, so supporting Docker containers, having dedicated hardware to support complex workflows, having support for custom queue configuration so that we can support real-time workloads and high-throughput type workloads. And JGI has invested in a dedicated partition on Cori to support their workflow, and so I'm going to be talking a bit about that in a minute, how that's coming together. So NERSC 9 is our next generation supercomputer. We announced this in November, and NERSC 9 will be deployed in 2020. And it's the first machine that we've ever designed with really the needs of simulation and data analysis on an equal footing. So it was designed to meet the needs of both our large-scale simulation users and the needs of the experimental facilities. So we've had some, what I think are really exciting new features in the way we're architecting this machine. For example, we have an all-flash file system. I think this will be really important for I/O and for accelerating some of the workloads that we have. We also have things like a specialized network interconnect that can support terabit connections to external facilities like the JGI for streaming data in. So this is coming in 2020. I should also point out this is a GPU-accelerated machine, and this is the first time that NERSC will be deploying a GPU-accelerated machine. So, as I said, the needs of experimental facilities are driving the way that we design our machines, but they're also driving the way that we plan and organize our work. So something that we've been working on in the last few months is projectizing a lot of the work that we're doing within NERSC to support experimental facilities like the JGI. So we do a lot of work beyond simply deploying hardware. There's a lot of infrastructure that has to be put in place to support the scientists that we work with, a lot of policy and configuration changes that need to be made, and this is a constantly evolving effort as we understand better and better the needs of our scientists. So we've put in place a project to coordinate this work across NERSC so that everything we're doing is really working coherently, because often these kind of technical tasks are done on a one-off basis, kind of in isolation. And that's something that isn't very sustainable for us, and also it doesn't really benefit the whole of our user community. So we've been really focusing on taking the requirements we have from our experimental facility partners and translating that into work that will benefit all of our users. So I want to talk a little bit specifically about JGI using NERSC. So JGI in 2018 used something like 15% of all the hours allocated at NERSC from the BER office. And in addition to that, there's something like 70 million CPU hours used on the gene pool cluster that we call de novo. Now, this is a set of dedicated hardware that runs a lot of the JGI workload, and that's going to be retiring this year. So a lot of the work that we've been doing at NERSC with the JGI NERSC team is transitioning that workload onto Cori, onto this dedicated partition of hardware that JGI is invested in on Cori. I want to shout out a great thanks to a lot of the NERSC team who's been working on this, in particular your JGI NERSC consultants, Kelly, Bill, Mario, and Jan, who've done a great job of leading this transition work and supporting the JGI needs as this is all coming together. I also want to give a shout out of thanks to two more NERSC staff who've been working very hard behind the scenes on the configuration and infrastructure needs to support these workloads. So thanks to Urshad and Brian. We're getting close to being completed with this transition. We've got something like 15%, I think, of the codes are still yet to go, but we're working really hard to get everything over the line, and we're really excited to see the science that you're all going to be doing using Cori. So thank you.